Hello there, cosmonauts! In today's episode of MicroCosmos, we'll talk about the Asteroid Impact mission, which is an ESA candidate mission currently in its late stages of conceptual development. The goal of AIM, as it is better known, is to launch the Asteroid Impact Monitor atop an Ariane 6.2 and put it in a heliocentric co-flying orbit close to binary asteroid system 65803 Didymos. Once there, the craft is to observe and map the system, mainly focusing on its secondary object, which is an asteroid roughly 165 meters in diameter, using infrared and high-resolution visible light imagers, as well as a high-frequency radar. The craft is planned to carry at least 3 smaller spacecraft on board, 2 3-unit CubeSats and a DLR-provided Mascot 2 lander, which is to perform in-situ measurements of both the surface and subsurface strength and porosity of the small moon. After full deployment, AIM is to act as a relay between the quartet and mission control back on Earth, a feat it aims to accomplish by establishing a high-bandwidth connection to ESA's optical ground station in Tenerife, Spain, using its onboard optical laser terminal Optel-D. The main scientific goals of AIM are to study Didymos' collisional and rotational evolutions, as well as the way in which they interacted with one another and interfered in each other's development over time. This mission is of additional importance because it is supposed to work in tandem with NASA's Double Asteroid Redirection Test, or DART spacecraft, as part of the larger Asteroid Impact and Deflection Assessment mission, about which we will talk more on Friday's Cosmocast. The end goal of AIDA is for AIM to observe the small moon, while DART, a vehicle known as a hypervelocity kinetic impactor, smashes into it at roughly 6 km per second. AIM is to then live up to its name by monitoring the ejecta caused by the collision, giving accurate readings on the change in its orbital dynamics, and making comparisons of the moon's structure before and after the impact. Pre-impact measurements will be taken during the first characterization phase from a distance of between 10 and 35 km. 2 weeks prior to the collision, this distance will be increased to 100 km to ensure the spacecraft's safety. Sometimes after the danger has passed, the craft will close in for a second characterization phase, the completion of which will mark the end of the mission. We here at Cosmocast have taken up the task of informing the public about AIM, because its future is still uncertain and will be decided in mid-December at the planned meeting of the European Council in Brussels. The more public exposure it gets, the higher the chance it will be approved, and if that happens, the mission will launch in October of 2020 and reach Didymos by June 2022. Stay tuned for tomorrow's MicroCosmos, in which Jared talks about AIM's cutting-edge comms system and ESA's plan to develop a high-speed data network in deep space. And if you found this episode informative, consider hitting that like button. And if you want to watch more, subscribe to our YouTube channel or visit our Facebook page.